All right, let's get right into it. Every once in a while in science, a paper comes along that's just so audacious. It claims it can rewrite pretty much everything. Well, today we're looking at one of those. A single paper that puts forward a truly revolutionary idea to solve some of the biggest, deepest mysteries in all of physics. And it really all comes down to this one simple question. What if the grand puzzles of the cosmos, the stuff that's had scientists scratching their heads for decades, what if it could all be unlocked by one single elegant formula? That's the bold premise we're going to explore. Okay, so before we can really appreciate the proposed solution, we first have to get our heads around the sheer scale of the problem. Modern physics is up against some absolutely enormous challenges. I'm talking about fundamental unknowns that are right at the edge of what we can even comprehend about our universe. Let's just start with how much we don't know. Just look at this. A whopping 95% of the entire known universe is made of stuff we call dark energy and dark matter. And the dark part is key. It's dark because we have no idea what it is. Everything we know, everything we've ever seen, every star, every planet, you, me, it's all packed into that tiny 5% slice. Kind of humbling, right? And that huge 95% mystery is really just the beginning. The to-do list for physicists is pretty daunting. We've got to figure out how to make the world of the very big, Einstein's relativity, play nice with the world of the very small, quantum mechanics. We have to figure out what the heck the dark sector even is. And then there's the fine-tuning problem. Why do the rules of the universe seem so perfectly dialed in for life to exist? These are the absolute giants that this paper is trying to take on. So how in the world does one paper claim to solve all of this? Well, it introduces a really radical idea. And it all centers on this one concept, a universal time formula. The key here isn't some new exotic particle or a weird hidden dimension. Nope, it's a completely new way of thinking about time itself. The core concept here is something called emergent time. The paper basically argues that time isn't a fundamental part of the universe's blueprint. It's not the fourth dimension we're all traveling through. Instead, time is an emergent property. It sort of pops into existence from something more basic. The relationship between an object's physical size, its geometry, and the ultimate speed limit of the universe, the speed of light. And it all boils down to this. This, right here. This is the formula. It looks almost too simple to be true, doesn't it? Just 3 little letters. But the claim is that this simple relationship holds the key to unlocking all those massive cosmic puzzles we were just talking about. So what does it actually mean? Well, T represents the typical timescale for any system. Like the lifetime of a subatomic particle, or the time it takes a galaxy to rotate once. R is that system's size, its radius. And C, well, that's our old friend, the speed of light. But here's the kicker, the really mind-blowing part. The claim is that this is universal. It supposedly works for everything, from a single tiny atom all the way up to the scale of the entire observable universe. Now look, a claim that big needs some serious evidence to back it up. So the authors tested it. They took data from 296 different objects, spanning an absolutely insane 41 orders of magnitude in size. And the result? They found an R-squared value of 0.952. Now, for any stats people watching, you know how wild that is. For everyone else, it means that this simple formula explains about 95% of the behavior they saw. It's an almost perfect correlation. Okay, so if we accept that this formula seems to hold up, what can it do? How does it actually solve those big puzzles? Well, let's start with the big one. That 95% of the universe that's been hiding from us, the dark sector. Right now, there are 2 competing views. The standard story in cosmology says we need to find some new exotic particles for dark matter and some mysterious unknown energy for dark energy. We've been looking for decades with no luck. But this paper's framework suggests something way more radical. It says, what if dark matter and dark energy aren't things at all? What if they're just illusions, ghosts in the machine, created by the geometry of space-time itself? So how does it explain away dark energy? Well, the paper says the expansion of the universe isn't a smooth, continuous process. Instead, think of space-time as breathing. It has these tiny, repeating geometric wobbles or oscillations. And these wobbles act like a ratchet, It clicks forward, but it can't quite go all the way back. Over cosmic time, This creates a net effect that pushes everything apart faster and faster. And that purely geometric acceleration, that's what we've been calling dark energy. No mystery fuel required. And the explanation for dark matter is just as clever. The idea here is that space-time has scale resonances. Think about pushing a kid on a swing. If you push at random times, not much happens. But if you push at just the right moment, at its resonant frequency, a tiny push creates a huge swing. The paper says gravity works the same way. At the specific scale of a galaxy, space-time resonates, which naturally makes gravity act stronger right at that scale. And that extra gravity is what we've been misidentifying as invisible matter. So this brings us to the paper's most incredible claim. I mean, if this one little formula can potentially explain away the entire dark sector, could it go even further? Could it actually be the key to unifying all the fundamental forces of nature into a single theory of everything? The argument is absolutely stunning. It says that this single principle, time is just size over the speed of light, is the one rule behind all four fundamental forces. They just show up differently depending on the scale you're looking at, whether you're at the tiniest possible scale of gravity, the scale of a proton with a strong force, or the scale of an atom for electromagnetism. It's all just different verses of the same underlying geometric song. So, where does all of this leave us? I mean, if any of this framework holds up, it forces us to wrestle with a truly mind-bending question about the very fabric of our reality. This quote from the paper really hits the nail on the head. Time is not a fundamental aspect of reality. Think about that. The idea that time, our most basic, intuitive experience of the world moving forward, isn't real in the way we think it is, that it's just a byproduct, an artifact of the shape of space and the speed of light, that is a massive, massive shift in thinking. And that really leads to the final lingering thought. If something as fundamental to us as time can just emerge from a simpler geometric rule, it really makes you wonder, doesn't it? What else about our reality is not what it seems? What other deep, profound truths might be hiding right there in plain sight, just disguised as something much more complicated?